All right, example number 9. Thought this section would never end, but here we go. This will be our last example for simplifying radical expressions. Super sweet. All right, so this is thrown in there now because this has to do with simplifying radicals. So this is why we put Pythagorean Theorem in there, and now we're going to find the distance between 2 points because, as you're going to see right now, it has to do with simplifying radicals. All right, so what I did was I created a coordinate plane right here so that I can show you just visually how to find the distance between 2 points. And really there's 2 approaches to this, and I'm going to show you one approach for part A and have a B example, and then I'm going to show you the other approach. And basically you can do either approach that you like because math is super rad like that. It's superly cool. Okay, so if I'm going to find the distance between these 2 points, what I'm going to do is I'm going to plot these 2 points right now on my coordinate plane. Okay, so I'm going to plot the point 2, -1. So I go over 2, and then I go down 1. Okay, so I got a dot right there. And then I'm going to plot the point 5, 3. So over 5, 1, 2, 3, 4, 5. And then I go up 3, 1, 2, 3. Okay, so I want to find this distance right here. And I'm going to use my cool little tool here. I want to find this distance right there. Okay? Now watch how cool this is, y'all. You're going to be like, dang, that is super rad. Watch this. I can go ahead and drop this line down. And I can just create a horizontal line from that point. And notice what kind of a triangle do we have? That's right, we have a right triangle. That was supposed to be a right angle right there. Let me just try that again. We have a right triangle. Okay, that probably looks better. And we learned from last example that every right triangle, you can find any length or the hypotenuse by using Pythagorean Theorem. Oh, dang. So watch this. Okay, how many boxes do we have? 1, 2, 3. So we have 3 boxes right there. How many boxes do we have right here? 1, 2, 3, 4. So 4 boxes. So now if I want to find this hypotenuse, you got the hint. You got this. You got this. We're going to use Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. So 16 plus 9 equals x squared. Add those guys together. I got 25 equals x squared. I want to solve for x, so I'll do the opposite of taking the square, which is square roots. And the square root of 25 is 5. And that's it. We just found the distance between these 2 points right here. Okay? And that approach was using Pythagorean Theorem. Okay, but there is another way to do that, and that is without the aid of a graph, and this is without using Pythagorean Theorem. All right? And you've probably seen this sometime before, and we're going to use this time called the distance formula. And what I'll do right now is write out the formula. If you're interested in the proof of it, or maybe like if you want to know where it comes from, or even for Pythagorean Theorem, I would love to send you a video, and I can let you see an approach of how you can derive the distance formula or derive Pythagorean Theorem. Deriving formulas is freaking awesome because you can see where they come from. But if you're like, nah, dude, I'm not even going to do anything with math after this class, you're like, I'm good, dude. That's fine. I won't. That's why I'm not going to do them on this video. But if you want the video, I got your back. Okay, distance formula. So what we're going to do is this, is that say if I have some random point called x1, comma, y1. Again, this is just a random point. It could be like our point -3, 2. And then if I have a second point, I'm going to call that x2 and then comma y2. Okay, so if I have 2 points, and if I'm going to find the distance between those 2 points, the formula goes as follows. D equals, for distance, the square root of, so in parentheses, x2 minus x1, you square that whole thing, okay? Plus, then take the y coordinates, y2 minus y1. You square that whole thing. And this radical needs to go all the way across there because the whole thing's underneath the radical. Okay, so this is going to be our distance formula. And I'm showing you this right now because the problem that we did in part A could have been used or could have been derived using the distance formula as well. So I just want to show you the Pythagorean Theorem and the distance formula, and you choose the one you like. Okay, so first thing, let's label our x1, y1, x2, y2. So x1, y1, x2, y2. Okay. So here we go. All we do is we replace the x1 with -3, the y1 with 2, the x2 with 0, and the y2 with -4. Just plug them in and simplify, and then we're done. So d equals the square root, parenthesis, x2. x2 is 0, 0, and then it says minus x1. Well, look, x1 is -3, so you put -3. And so I guess the trickiness right there is because it's a -3, so you got to put a parentheses to just show that you have it's minus a negative and squared plus y2. y2 is -4, so -4 minus y1. y1 is 2 squared. Now let's just simplify this, and then we're going to be done. 0 minus a -3. A double negativo equals positivo. So this is going to become positive. This right here is going to become 3 squared. Okay, 0 plus 3 squared plus -4 minus 2. Well, that's a -6. So that's going to be -6 squared. Okay, so basically I just simplified everything that's inside of the parentheses, and 3 squared is going to give us our 9, and this is going to give us our 36. Okay, and all we have to do left is just simplify this, and then we'll be done, which is the square root of 45. Okay, but since you guys have awesome simplifying radical skills, let's simplify radical 45. And I believe that's going to be radical 9, radical 5, right? Because 9 times 5 is 45. And 9 is the biggest squared number that goes into 45. So that's going to be 3 radical 5. Okay. So you can use either the distance formula, which I show you down right here. You can either use this formula, okay? Or if you want to get some graph paper out and you want to graph the 2 points and make a right triangle, you could use Pythagorean Theorem. Both answers would give you the exact same answer. So if you want to try this first problem out again, using the distance formula, you should get 5. And same thing, if you try this problem using Pythagorean Theorem, you should get 3 radical 5. Same thing.